Okay. Morning, everyone. Am I audible to you guys? Okay. So I hope all of you just no doubt in Chinese remainder theorem. Okay. So I hope you guys already understood how I got 2 from 77. Quick, if you didn't understand anything, how we get xi. Okay. Okay. So Chinese remainder theorem. Just remember, suppose you have a series of mathematical equations which are in this congruent forms, okay, then for this type of equation you can find a unique solution for x with the help of Chinese remainder theorem. So before doing that you have to check whether these values are co-prime or not. Okay, if these are co-primes, then only you can use Chinese remainder theorem to find the solution for x. Okay, so Chinese remainder theorem you can just find out with this equation. Okay, it will be mi xi ai and so on, or it's a summation of all these values. Okay, this mi is nothing but m divided by small mi. Now m is, you have to just check how many equations are there. Okay, then if there are three equations, then you just need to multiply these values. Okay, these are your m and these are your a. Okay, it can be anything. Okay, it's not mandatory that you will just use these values ax anything. Just remember, one, these are a values and these are I considered m values here. Okay, so you just need to calculate these values first. Okay, if you are calculating m1, okay, if you are calculating m1 for this one, then you just need to multiply this m2 and m3. Okay, if you want to calculate m2, you just need to multiply these two values. Okay, m1 and m3. And if you want to calculate m3, then m3 will be your multiplication of m1 and m2. Okay, so in this way you can just calculate your 77, 55 and 35. Okay, and m is the multiplication of all these m's. Okay, so total is your 385. Okay, now we need to find xi as per your this one. We have calculated mi, we also know ai. The main thing is xi. Okay, so xi is the inverse of your mi. Okay, mi we have already calculated, but we cannot just directly derive it from m1. So to find the xi, we are using this equation. Okay, that means mi into xi divided by m1, remainder will be 1. Okay, so this is a congruent equation. This equation we can just simply uh, remodify into this equation. These are equal. Mix m1 x1 congruent to 1 mod m1 is equal to mixy mod m1 equal to 1, means this term divided by m1 is 1. Okay, so first is m1. M is 77 x1 and mod 1. Okay, so in here we need to find a xi such a way that if we divide that term by 5, we will get remainder 1. Now you have one option is that you will just, it's like hidden trial method. You will just start from 1, then check, means you can start from 77 by 1, then divided by 5, then 77 by 2 divided by 5, then you will just check out each value of xi such that you get a remainder 1. Okay, this is one method. The second method is that the simple way which I have done here, you can simply divide 77 by 5. Okay, this 77 divided by 5. So whatever will be the remainder, you can just place it here. This 22 is the remainder of 77 by 5. Now if you divide 77 by 5, what will be the value such that you get 1 5 into what? 77. Yes, 55. So 55 into 5, 75. So 77 minus 75 is 2. So this is the remainder, 2x1, 1. So this is a bit smaller version. So if you make it a bit smaller, then it will be easier. But ultimately method is same. Then you have to find the value of x1. Sorry, this is x1. x1 such that if you divide that whole thing, this multiple of twice x by 5, remainder will be 1. Okay, so for this twice xi, if I put 3, 3 into 2 is 6. Now if 6 divided by 5, okay, so remainder is 1. So x1 is 3, right? 3 into 2, 3 into 2 is 6, 6 divided by 5, and remainder is 1. Okay, so same thing is here as well. 55 x to 7. So you just do 55 divided by 7, and the remainder is your 6. How? 77. 7 into 7 is 49. 55 minus 49 is 6. X2 by 7. Okay. Now x2 equal to 6. That means what? 6 into 6. What's the value? 6 into 6. 6 into 6. Okay. 36. 36. 36 divided by 7, remainder will be 7. 7 into 5, 35. 36 minus 5, remainder is 1. Okay, so same thing is here as well. Okay, 35 divided by 11, the remainder is 2. Okay, then again 6 into 2, 12 divided by 11, 1, and remainder is 1. So this is how you find out value of x1, x2, x3, or you can say xi's. Okay, so one method is you will just try its hidden trial method, or you can say brute force method to find the value of x, or you can just divide this number with this number, means a divided by this one, whatever will be remainder, that will be a bit smaller. x3 is 2 now, x3 is 6. X3, oh yeah, got it. This is x3. 6 into 2 is 12. Okay, 12 divided by 11 will be 1, remainder will be 1. Okay, so that's how you will find the value of xi's. So after you find out xi's, that means x1, x2, x3, then you will just put in this equation. Okay, m1 x1 a1 plus m2 x2. So this will depend on the number and the value we have to assume. After it's not assuming, you it's like brute force, means you will try each of the values. You just start from 1. If 2 into 1 divided by 11 is remainder is 1, then it's fine. If not, then again you go for 2, then 3 and 4. Okay, this might be a tedious one. That's why if you make it 35, keep it 35, it will be more tedious. Okay, if you make it a bit smaller, then also the same process, but you can try with lesser number. Means there will be less number of guesses for x3 or axis. So after this, you will just put it in this equation, just multiply as per the equations mod 35. So once you add these things, the answer is 1191 mod 385. Again, it's a very big number to find the x. You have to find out a value of x such that 191 mod 385. You just need to multiply, sorry, 91 divided by 385. You can use calculator or you can also try it directly. But another method, if you don't have calculator, you can use this method. Simple way. So you will simply subtract this value from this one, 1191 minus 285 806. So you will continue this process until you get a value which will be lesser than 385. Okay, you have to find any number which will be lesser than 385. Okay, then 806 is bigger than 385. Again, you minus this 385 from 806, value will be 421. Again, it's bigger than 385, so you will do the same process. 421 minus 385, 36. Now 36 is smaller than 385. That's the value. This is just a simple technique when you don't have any calculator. If you have calculator, you can just check what will be the 1191 mod of 385. Okay, now if you want to verify whether it is correct or not, this is your actual x 36. So you can just put this value in all these equations. Okay, these are the main equations. So 36 mod 5, 7 into 5 35, 36 minus 35 1, so this is correct. Then again 36 mod 7, 7 into 5, same equation. 36 minus 5, remainder is 1, correct. Then for 11, 36 minus 33, 6 minus 3, 3, so this is correct. So 36 is the answer. Okay, so before applying this formula, just check whether these m values are co-primes or not. If yes, then only you can apply this method. Okay, I hope it's clear now how you get xi value. Okay, okay. So next just topic I start is message authentication and hash functions. So in this part, we mainly check with the message authentication and how we use hash functions. Okay, so message authentication is mainly concerned with like protecting the integrity of your message, whatever message you send to a particular person. And we also need to validate the identity of originator and non-repudiation of the origin. So message authentication mainly concerned about these three things. Okay, so for message authentication, we have three different techniques. Okay, so with one is message encryption, one is message authentication code or MAC, and third one is the hash function. So with the help of these three things, we can um, just satisfy the condition of message authentication, or you can say we can provide message authentication. Okay, so first one is message authentication. I guess you guys already know about message encryption is just all those encryption techniques we have discussed till now. Okay, So message on encryption provides your message authentication as well, which was the first condition for any cryptographic or encryption algorithm, right? So it just provides a measure for authentication. So if you use symmetric encryption, then receiver knows that sender must have created it. Again, only the sender and receiver will know the key, because in symmetric key, your key is just shared one, right? So next, if you use public key cryptography, encryption provides no confidence of sender, because it uses a public key, and public key is known to everyone. So there is no confidence who is the actual sender. However, if sender signs the message using a private key, then encrypts with the recipient's public key, then it will have like both confidentiality and authentication. But the cost is that it requires two public keys. Okay. Next is your message authentication codes. I will not just describe about message encryption much, because all the time we have just discussed about encryption processes only. Okay. Now what is MAC? Okay. So MAC is like a algorithm which is similar to your symmetric key cryptography, and it will provide your message authentication. Okay. So for establishing a MAC process, the sender and the receiver share a symmetric key, and key can be any, for example, it's just K. So essentially, a MAC is an encrypted checksum. Okay, checksum generated on the underlying messages that will be sent along with a message to ensure the message authentication. It is similar to digital signature, but remember, this is not digital signature. It's kind of signature, but it is not digital signature. Instead, it is just a checksum. Okay, and it is a many to one function. Okay, so many messages might have same MAC, but finding these MACs will be very difficult. Okay, so what are the requirement of MAC? First, knowing a message and the MAC. So if you want to uh, for the MAC protocols, you need to find out what is the message and the MAC, and it is infeasible to find another message with the same MAC. And MAC should be uniformly distributed, and it should depend actually on all bits of the messages. Okay, since with the help of certain algorithm we create MAC, so we have to make sure that all the bits of the messages will be involved when we generate a MAC. So this is the main process. So here you can see the sender uses some publicly known MAC algorithm. Okay, there are lots of different MAC algorithms. So it will just use any MAC algorithm, and that MAC algorithm will be publicly known to everyone. Then it will input the message and secret key K with the help of secret key, and it will produce a MAC value. Okay. There will be a key and a message, and with the help of MAC algorithm, it will generate a message. So the whole message will contain both the main message and the MAC. Okay, then it is also kind of similar to hash, but MAC function also compresses an arbitrarily long input into a fixed length. Okay, since it just compress the value of the input message, it is similar to hash. Again, it is not hash. Okay, the major difference between hash and the MAC is that MAC uses a secret key, but hash never uses any secret key. It uses certain functions but not key. Okay, now sender forwards this message along with the MAC, and here we can just assume that the message is sent in clear, means there is nothing wrong with that message, as we are concerned of like providing message origin authentication, not the confidentiality. So if confidentiality is required, then we need to again message encryption. Okay, with this help of this MAC we are just providing authentication, not the confidentiality. Okay, if you want confidentiality then you also need to provide some encryption technique. So on the receipt of the message, on receipt of the message and your MAC, the receiver will feed that received message and the shared secret key K into the MAC algorithm and recompute the MAC value. Okay, now receiver will know the checksum. Okay, so if they are equal, means this satisfy the condition of equality, means both the received and computed MAC are same, then it will know that the message is authenticated. It is sent by the proper or accurate sender. Okay. Now, if computed MAC does not match with the MAC sent by the sender, the receiver cannot determine whether it is the message that has been altered or it is the origin that has been falsified. Okay, so as a bottom line, we can say a receiver safely assumes that the message is not the genuine. Is this MAC process clear to everyone? MAC is just a checksum, and with the help of MAC, we just provide authentication, not the confidentiality. Authentic message authentication means what? We need to verify whether the message is sent by the particular or genuine or legitimate sender or not. So it just provides authenticity, not confidentiality. So to generate MAC, there are different MAC algorithms, and with the help of that key and the algorithm, they generate the MAC. And MAC also compresses the message, then it sends it to the receiver. Then receiver will have a key to it's like symmetric encryption. I said the key will be shared in for both parties. Then receiver will use the same key and same MAC algorithm to compute the recompute the MAC. Then it will just check whether computed MAC is equal to the received MAC. If it's equal, then the message is authenticated. Otherwise, it's not. That's the general process. Is it clear? Yes. Yes. Okay. If MAC is clear, then I'll just move to the other one, which is your. Hi. Oh, so okay. Next is your what are the limitations of MAC? Okay, MAC also has certain limitations. Okay, what are the limitations? One is the establishment of shared secret and other is the inability to provide non-repudiation. Okay, these are the two main limitations of your MAC. In case of establishment of shared key, it can provide message authentication among like pre-decided legitimate users who have shared key, but this requires establishment of shared secret prior to the use of MAC. Okay, and again non-repudiation is like assurance that the message originator cannot deny any previously sent message and commitment or action. So MAC technique does not provide a non-repudiation service. Okay, this only provides authentication. Because remember, for encryption we have another term in need to satisfy is the non-repudiation, where both sender and receiver cannot deny that they have sent the messages or received the messages. Okay, MAC is only provide the authentication. Okay, it have to just tell you that the sender have sent a message. But again, in the end, the sender might say, no, I haven't sent a message. Okay, so MAC technique does not provide that non-repudiation because it cannot just provide any proof. Okay, though like no third party can compute your MAC, it's very difficult to find a third party to generate the MAC or recompute the MAC. Still, sender could have denied having sent the message and claimed that the receiver forged it. So, as it is impossible to determine which of the two parties computed the MAC. Okay, so these two are the main limitations of MAC. One is establishment of shared secret, and another is the inability to provide non-repudiation. So next later we have digital signatures. I guess digital signature part is already covered by Irene ma'am. So these two limitations we can overcome with the help of digital signature. Digital signature, which is like public key based digital signatures. Okay, is Mac clear now? Limitations, why these limitations and all. Okay, so next is hash function. Okay, I hope you guys have some knowledge about hash function already. Hash function was only already included in your data structure syllabus. So what is hash function? It's just a mathematical function, okay? It converts a numerical input value to another numerical input value. But the main advantage of hash function is that whatever will be the input, the output will be a compressed version. Okay? The input of a hash function can be of any arbitrary length and the output is always a fixed length. Okay? So values returned by a hash function is also known as your message digest or simply a hash value. Okay, so usually we assume that the hash function is public and not keyed, and that's the main difference of hash with MAC. So hash mainly used to detect changes to the message, and it can be used in various ways with message, and mostly it's we use it to create a digital signature. So any hash function we can just represent with the help of this function. This can be anything. You can also say h of x equal to x and all. Okay. Okay. Before telling you the process of hash function, yeah, this is the main thing. If there is any message of arbitrary length, we can use a hash function. Then we will get a value. Okay. Are you guys clear with the hashing? You guys know about collisions, hashing? How we find hashing? What is collision? What is the collision handling process? Okay, yes. Can you tell me what is collision? Ma'am, hash function detect only. Detect only means detect what? Hash function here
Ma'am,
we are using for
collision
message
is the
authentication.
process in
Authentication hash function we are going to use in digital signatures and all. So hash function what we do if we give oh hash function detects no it's not detection. Hash function is just a function. What is hash table? You guys know what is hash table? Message digest. Yes, you guys know. So what is collision? Can you tell me? Message digest
collision
or
is
hash value is the. Okay, you're saying something. You're saying
yeah, collision is the process in which like If we are putting an input from the hash, means the arbitrary means whatever it is given the input to the table, then if we are putting the same number of values, the same amount of values in an index two times or three times, that process is called collision.
Yes, correct. Exactly that. Okay. So for the collision, we have different collision handling process. Can you tell me what are the collision handling process? No idea. Okay. Collision handling means we know there are collision. Okay. When collision occurs, for example, 8, 3, 13, 6, 4, 10. These are the keys I have. Now I will have a hash table. So I'll have a hash table, for example, where you are going to take the input from this is, you can say, key space, and this is your hash table. Okay, so there will be a hash function. Hash function can be any function. You can just use any hash function as per your convenience, but the very basic one is like your x, what size. Okay. Okay, why we need hash table actually? What's the main purpose of hash table? You guys know about direct addressing? Direct addressing, direct access table. Random access, not direct access table. What is this? It's also a kind of hashing thing. So hash table is your modification of direct access table. So what happens in direct access table, whatever will be the key space, we are going to insert that value to the particular index of the hash table, or in this case just think about a table. So whatever will be the value, you will insert that value at that particular index. Okay, so here my value is 8, so I'm going to insert this 8 value in the index 8. Okay, so my value is 3, so I'm going to put it in 3. This is direct access table. Okay, now here I have 13. Okay, and the table size is just 10. So that means what? This is a problem, right? My hash table is limited to 10. Now I have value 13, and which is like not available in the hash table, direct access table. So this is a problem. That means your hash means that table have to be dynamic. If you can dynamically allocate, then it's fine. If it's 13, if you need, you can just add some more memory to your table. But the thing is, there will be lots of empty spaces, and which is like wastage of your memory. Correct? So to solve this problem, we use hash table. That is why we have hash function. Yes, exactly. That's why we have hash function. So hash function will do what? You can have a limited number of table. With the help of hash function, we can just uh, with the hash function we can just take that key value and put it a bit small number of hash table, and and it's again there will be certain problems. It's not like every time we will have like means easy for us, but again there will be some problem with the space. Okay, it's not like fully you can get rid of that size, a hash table sizing problem, but still it's a better way. Okay, we will just use a hash function. This hash function is arithmetic function which will take the input and um, just map into a particular location. Okay, these things are also called as bucket, you can say. Okay, so for example, here I am using x size, this is our hash function. Okay, so here I can say it's 10 because size of the table is here. So if I use this hash function, now I'll use this hash function. Okay, if I use hash function, then I don't need to store the value at the particular index. Now if I do 8 mod 10, it's again 8, right? So I can store that value into 8. Now 3 mod 10, I can store this value 3 here. Now I have 13 mod 10. Now 13 mod 10 is 3, so it will go to this location. So this condition is known as your collision, because two key spaces means after applying your hash function, it's just getting the same location, and which is a problem. We don't want that, and this particular condition is called collision. So what is that means we cannot get rid of collision. We can never get rid of collision. What we can do is that we can reduce the number of collisions. So for collision handling, we have two options. One is called chaining and other is called open addressing. Okay, this is kind of extra thing I'm telling you guys. These things are not in CNS parts. So anyway, you guys should know about this collision handling techniques. So these are the two main things. Again, for open addressing, we have different type like linear probing, then quadratic, then we have double hash, and all. Okay, there are different types. Okay, and other is chaining, one is open addressing. So these are the main category. One is chaining, another one is the open addressing. So what is chaining? What is chaining is that instead of storing the value directly into the table, we will store the value in the form of a linked list. Okay, so here what I'm going to do, I'm not going to store the value here. Okay, instead I'm going to store the value as a form of linked list. Okay, I'm just deleting this portion here. I'm just going to store the value in a node. Okay, okay, so here also I'm not going to store the value, I'm just going it to store it in case of linked list. Okay, so next 13, same tree. So I'll going to just add another node for the 13. Okay, so whenever you want to find where is 3 and 13 and it's showing the same index, so in the same index, in general way, we cannot store two things, but when we use chaining, which is linked list, we can just store many as many values as we want. Okay, next is your 6 not 10. So value is 6 again. So instead of storing there directly, I'll keep in the form of linked list and so on. Okay. So this is your chaining process. We are not going to store in the hash table. Instead, we will keep in the linked list form. Okay. Now what is open addressing? Now open addressing is what? Open addressing, we will not use any linked list. We are going to store the values in the hash table itself. Okay, again just come to this portion. Okay, first value was 8, I'm just using it. open addressing. Okay, so value is 8. I'm keeping 8 here. Now value is 3. 3 will come here. Now 13. 3 and 13 collision occurs. So what I will do, I'll store the 13, whatever will be the next empty space. Okay, so since this index is already occupied, I'm going to store 13 here. Okay, next I have 6. 6 will come here, 3 coming here, 13 coming here. I'm storing here. Now comes 4. Okay, for 4, index is 4. Now you can see 13 is already occupying the index 4. So I cannot put it there. So what I will do, I'll just store the value whatever will be the next empty space in the hash table. So instead of 4, I will just store in the next value, which is index 5. Okay, for 10, it will just go to here. This is your open addressing. Whatever open space is available, we are going to store the value there. Okay, is this clear? Chaining and open addressing. Chaining and open addressing, clear? These are the two main techniques to handle collisions. Is it clear? Chaining and open addressing. Phone number কাৰো নাই এডমিশন সুধিব লাগিব এডমিশনৰ নাম্বাৰ দিয়া আছে চাগে সাইটত দিয়া নাই নেকি অ ইয়াতে সব আছে ঐ এইটো আছে আৰু তাতে আছে এটা লৈ গলে হয় Is it clear or not? Ma'am, due to network problem, I cannot go to the video later. Okay. So this is chaining and open addressing. Now let's see what is linear probing. Okay. Linear probing, what we do is that we just modify the function into a function. This is our original function. Okay. X size. So in case of linear function, we will just modify it into h dash x, h of x plus f of I. Okay, and size will remain same. This is our modified version which will we use linear probing. So for linear probing, the value of fi will be I, and I will start from 0, 1, 2, 3 and so on. Okay, so now you see what will happen if you need again will check the same thing. Okay, I want to draw it again, but anyways, okay, just get it from here. So first, let's see our collision occurs at number 13, right? Rest is same, so you can just find out hx, then h of 13, then f of I is just start from 0. Okay, I value will start from 0. Don't confuse it with the index. Okay, I is just separate. I will just start from 0, 1, 2, 3, 4. So first you will try with f of 0. Okay, and rest will remain same. Size is 10. Okay, h of 13 is already 3. Is our same thing, 3, and 3 plus 0, f of 0, f of I equal to I. Okay, so f of 0 will be 0 again. So this mod 10 again it will be 3. Okay, now 3 is already occupied by 3, the previous one, correct? So what I will do, so find the next value. Okay, again h dash 13, h of 13. Now you will just increase the value of I. First you tried with 0, then you tried with 1, rest is same, 10. So in this case, this is 3 plus f of I equal to I, that means f of 1 equal to 1 mod of 10. So this is 4. 4 mod 10 is 4. Correct? So that's how we inserted value of 13 in index 4. Okay. It's kind of brute force. Yes, not exactly brute force. Which one is brute force you are talking about? I just got confused. Linear. Linear is not brute force. It's just same concept I'm saying. Whatever address will be available, we are going to insert it in there. Okay. Just I'm giving you the maths behind it. Okay. The maths behind how we can just find the location. Yes, finding fi again and again. It's not exactly brute force, but if you directly see the hash table, it's easier. I saw she already occupied 4 was empty, so I inserted 4 there. So when next I found 4 here and this space was already occupied, I just placed it in next available space. If next one is not available, again go for the next one, again go for the next one. Yes, finding location using open addressing is like that. It's recursive process. If you don't find a space, find a second next space, again find a second next space, and again find the next second space. This is I'm just giving you the mathematical equation. Okay. Now in case of quadratic, everything remains same, just that for quadratic this f of I will be I square. Okay. Then again this values will be same. I will start from 0, 1, 2, 3, 4. It's just to find the location. But if you directly search space are greater, exactly that's the thing. Search space are greater than hash table. See, in quadratic we have this problem. Okay, so okay, let me tell you one of the problem with the linear probing. See here, you can see that most of the keys or places are just in one place, so it forms a clustering problem. That means what? All the values are just compact or clustering in just one places, and rest of the hash table is just empty, so it's again a problem. Means it's not desirable. So we can use quadratic. So if we use quadratic, then at least there will be some gap. Okay, but yeah, again the problem is what you just mentioned. Now it's about the space size and the size of the table. So if your hash table is dynamic, then it's fine. So we always maintain a load factor for that. Okay, you always maintain a load factor. So load factor will mainly will be all the keys divided by size of the table. Okay, always we maintain a load factor for the hash table. Okay, that is so why we use mainly hash table, so that our searching becomes, we can find anything in one time, just single. We can just find the value and find the index, we just get the value. So main why we need hash table is just to make search complexity to be of 1. But we can see that if we use linear probing or quadratic equation, because we need to find the next available space, in that case our time complexity is not O1. It will be more than O1, but it will be again less than O of n. Okay. So it's desirable that search complexity is O1, but the thing is how it will be O1. No, it won't be O1 in linear. It's just desirable. I told you, like collision, you cannot get rid of collision. You cannot get rid of collision. You just have to try that collision number of collision is minimized. So for general hash table, it should be like O1, but because of collision and we have different technique, the search won't be actually O1. It will be more than O of 1. Okay, it won't be O1 in linear or again in quadratic or other. Okay, that's the main idea behind your hashing or hash table. So your load factor, you can say the total number of items stored divided by size of the array. Stored. Okay. This is the load factor. So we have to find out a load factor for the hash table. So whenever we see load factor means we have to put a threshold on that. So whenever we see that load factor is exceeding the threshold value, then we have to allocate some more memory. Okay, and if it's dynamically allocated memories, then it's fine. Then it won't be a problem. But if it's static, then it will be a problem. I went for quadratic one. In using the quadratic one, we can avoid the clustering problem. But again, the searching uh, might not always take one time. Okay, by concept, like generally, searching should be O1. But if we use linear, it won't be O1. It will be more than O1. Okay, is this clear for everyone? Hashing. This is just extra concept I just gave you guys. Okay. Okay. Okay, so just remember linear and quadratic. The f of I for linear it will be I. If quadratic it will be I square. So whatever value is here, you have to just I square. If 0 is 0, 1 is will be 1. If it's 2, it become 4. So you have to 4 plus, for example, 3, 7. You can put something in place 7. Something like this. That's how you find the thing. Okay. So I guess I should end it now. Okay, just let me. So okay, features of hash table. Okay, I can just tell you the features of hash table. What we use in cryptography, it should be fixed length output. I already mentioned that. Efficiency of operation. Generally, any hash function each with should be like fast operation, and computationally it should be faster than your symmetric key. So hash technique is very generalized. It's used like everywhere, starting from the data structure and all. Same hash function is also utilized in case of your encryptions. Sorry, not encryption, authentication. Okay, encryption means we mainly use it for digital signatures. So as you guys already know, it's known as message digest. So we have certain different algorithms, MD5, MD2, 4, and all. Okay, there are certain properties for hash function we use in case of cryptography. One is like image resistance. It is like this part is theoretical. So these are certain just properties. One is image resistant, second image resistant. First image means it should be complete. Yes, BMW glass. Okay. Okay, I just end it here. So we'll next class next week. That will be New Year. Anyway, see you guys in next year. Okay, I just stop sharing, take attendance. Okay, thank you. Thank you all. I hope it's clear to all of you.